So it's my honor to talk about interactive intelligent systems. Before I start, I want to mention that this is not really representative for the group as a whole. I mean, basically half of the team works in one way or the other on interactive intelligent systems. So this is a rather, I would say, random compilation of what's happening in my group, or not in all the different groups. Now, you know, I'm from the Analytic Computing Research Group, and only like a slice of that really deals with intelligent interactive systems. And we're very proud that we have this team which has this exist research transfer, which turns some of the basic research into products. So it will be a little bit application-oriented talk, so I hope you don't mind with that. And just to give you the context for that, I mean, a lot of that research really comes on my background from knowledge graphs and semantics, and looking how do semantic measures actually fit into various application cases, whether it's natural language processing, where I started off, or what this talk is about today, namely the combination of artificial intelligence and human-computer interaction. So, what is the general problem that we try to target there? I mean, when you consider a human-to-human dialogue, then we talk about the semantics of this communication act. Yeah? We need to sort of like understand what is the meaning of what the other person tells to us. Now, when instead of a human-to-human dialogue, we have a dialogue between humans and some sort of machines, whether that's a web page, whether that's some car that you try to engage with, or some robot interaction, you have a similar problem that you as a human, you try to find out what is actually happening on this user interface. What's the meaning that you're interested in? And then when you imagine that there is someone that you tell how to operate this interface, then there is the need to understand what does the human user wants, what is offered on maybe such a legacy interface, and how can you translate between these two. So there is a need then to understand what is going on with regard to the semantics of these different types of user interfaces. And then, of course, able to engage with them. And engagement can, of course, be very different. Actions can be speaking, can be touching, can be nodding, humming, frowning, pointing. So the question then is, how can we translate such kind of actions into an arbitrarily given human user interface? And these are the questions I want to cover then in my talk. What is the semantics of a user interface? How can we understand it? What are some of the means? How to recognize them? How to use them in order to translate for users also who have specific needs. So on the first step, a project we are currently working on is dealing usability analysis with artificial intelligence. So the purpose is to understand your users. So what is the classical way? So this is actually a typical user interface that you have for usability analysis. That's the one that previous spin out of my group is offering to users. And you basically have, for example, websites or other kind of interfaces. You define your areas of interest, and then you study how human users look at it, or how users interact with them, for example, with mouse. And then you find that there is some negligence on some of the interfaces that you are interested in. And of course, you may have clicks that you also notice and that you try to analyze on how users are engaging. The problem then is that not all the users encounter the same user interface. They have very different experiences. So here we have 4 different users working on the same website of the National Institute of Health. And depending on how they proceed through the user interface, they have a very different experience. So the question then is, how can we understand whether these users have a good experience with the user interface? How can we notice whether something that we want to promote is actually successful, and if it's successful or if it's not successful, for what reason is it successful or not successful? We cannot simply say, okay, we have a lot of clicks or not a lot of clicks, because that's a too shallow understanding, given that what these different people see is actually very heterogeneous. So in classical usability analysis, what you try to do is you try to mine data for correlations of stimuli. And classically, these are static stimuli. You have a web page which is static, which doesn't really change. Maybe you do a little bit of scrolling, but that's about it. And then you have clicks, gaze, maybe some voice interaction or emotion. Deki will talk about that in one of the postdocs' talk. And so by observing this action or non-interaction, you try to derive some improved usability. So these are passive stimuli. But nowadays, what we really want to have are very active user interfaces. So where you scroll, where you activate something, where even the user interface itself shows some active engagement, showing you some video or some carousel or the like. And that is very difficult to sort of like align an understanding of the different people and how they experienced actually the web interface. So we have a certain methodology from that where we try to support the usability expert on the right hand to understand how the different users have interacted with the user interface. And the idea is that we try to learn from some expert about what he considers to be a meaningful difference. So annotation of our data looks as here. You have different web pages where you have some transition, some activity is happening, and the expert determines, annotates whether this visual change was of importance or not. Isn't that trivial? No, it's not trivial at all, because currently you have a lot of activities going on where many of them are not very relevant. You have some scrolling activities, and then maybe something scrolls past or so, which really doesn't mean anything for the usability analyst. So it's not simply a pixel-based comparison that you can do where you would try to understand what is meaningful or not, but you really need to distinguish from a human user point of view what is a semantically meaningful difference. So, I mean, we used very old-fashioned kind of features to learn. One reason being that we didn't have a lot of data, so deep learning is not easily done. I'm sure we can do more on that in the future, but that was like very simple stuff that we engaged there. We provided the different data, some of which was annotated to the framework, and the output of the framework is then a summary of how the different users interacted. So how did the different users interact? You see, for example, this person which is visualized here with red dots, so there maybe was some eye tracking happening, and you see how the eye gaze moved over the screen. The same for the blue person and the yellow person. What is specific here is that this summary never existed like this. This, what you see here as one screen, never was shown in this way to the user. It's rather that it's compiled from different screens in order to be able to show how different people interacted. And for this, of course, so this is a very long screen. This includes scrolling activities, if you like. But then you also have to distinguish what if there's a certain menu opening and there are some activities on this menu. And you have to distinguish whether this is a stimuli which is different from that one, different from that, and different from that one. And still you want to recognize what are the similar stimuli that people have experienced over their periods of engagement. Because you want to know how people react to this stimuli, and you want to have a rather compressed representation of the interaction which is happening there. So this is part of this project where Deki will also talk about a little bit. And the core idea is that when we have this visual stimuli where we want to understand how users interact, we want also have a multitude of data that allows us to do so. So one very simple extension is to have a thinking aloud protocol of the users. But then when we look at eye and mouse tracking, we have a high spatial resolution of where people are engaging. But we also want to know with emotions where are they engaging in a beneficial way, in a way that they like or which they don't like. Getting to the second part of my talk, inclusion by semantics-based adaptation. This is about semantics of the user interface that we want to reuse because we all are disabled, either temporarily or permanently. So I remember like working on a laptop with my then baby on my lap, yeah, and so typing with one hand. That's one of the sort of like still nice ways where you're in a certain way handicapped. Of course, other people are permanently handicapped, and for all kinds of reasons. Maybe you cannot engage with your hands, maybe you cannot engage with your voice, maybe you have all kinds of restrictions. We had one EU project where we specifically dealt with severely handicapped people. For example, Udi here in Israel is tetraplegic, cannot move from the neck down. And so we played around with different user interfaces in order to help these people and adapt default user interfaces for their needs. Other people were Parkinson patients or had neuromuscular diseases. So one specific way which we investigated then was to use eye gaze in order to control the computer. So classically, one would use a default eye gaze interface, and these eye gaze interfaces also offer possibilities to simulate mouse and keyboard. The problem, what then happens is that if there's a user, the mouse or the keyboard has to be simulated and worked upon with your eye gaze, and it's a very fine-grained interaction, and it's very naive. The problem with the naivety is that how to best use your eye gaze for interaction needs to be determined by the actual user widgets. For example, when you go to YouTube, and the user interaction that is expected from you as a user is that you hover over the video with your mouse, and only then you can interact with the video in a meaningful manner. With a naive emulation, you don't even have the possibility to hover over a video. So the naive emulation, which doesn't understand what the widgets are, cannot translate this gaze activity into a meaningful interaction. So it's not possible to really well operate an arbitrary interface only by faking mouse, faking keyboard. You really need to sort of like know what is happening at this legacy interface in order then allow you to point and choose. So that's why in another framework that we presented, ACM Transaction on Chi, we determine the semantics of these user widgets, whether that's text input or hyperlink or video, and then you can also support particular modalities. For example, it's very difficult with eye gaze to very precisely locate an interaction that you want to execute. Yeah? With mouse, if you don't have a tremor, it's rather easy, if you're not on train maybe. But if you have to use something like gaze or another kind of joystick, it may be very difficult to move to a particular place. So you need the semantics. Then you can optimize the user engagement for the semantics so that the user who is handicapped needs fewer interactions and has less overhead for monitoring. And then you can adapt the type of interaction, translate the input to different modalities. And one big problem is that you need a high adaptiveness because the different users are handicapped in very different ways. Some cannot, for example, not operate any hand at all, like tetraplegics. But for example, Udi had actually constructed a mouse that he put in his mouth and operated with his tongue. And moved around like, and actually did computer work with that. Other people use some button that they push with the feet. So there's some people like blow into a particular device. So there's a large variety of user interfaces that you want to reuse even for very classical user interfaces. So we did specific experiments with these 3 different user groups. And what was particularly astonishing was that after some years after the experiment, so the project ended in 18, like in 2020 I think it was, some of our friends in Greece came back and said, actually, some of the people still use your browser that where you support this gaze interaction with. And so that gave rise and motivation to Raphael and some of the team to actually say, let's try to put this into some commercial product, which is not the case yet, but which is part of this XIST research project. And here you see some recent video from what is possible now. Now the steering of this mouse cursor is pretty much standard. It's done with observing the head with the camera. And so just by moving your head and tracking the head, you can here select different options. What's important to know here is that you need to understand what's going on the user interface, because depending on what you hover over on the user interface, different activities have to be chosen. And you even need to sort of like recognize what's going on. For example, there is some machine learning going on for recognizing icons and translating these icons into corresponding interactions. So this is how specific support is then possible, but also adapting the user interface to large enough areas, because I mean obviously operating with your head also doesn't have the same kind of precision that you have when you have a very fine-grained mouse interaction. And you can use this very same system and extend it. Now here in this first video, we only had movement, and by resting on a particular place for longer, then you would select it. And you could also switch on or switch off this selection possibility. But once you know about the semantics of the user interface, you can here, for example, use this foot button. And that, of course, when you can have this additional modality, it makes it easier to do the very same selection than what before you had to do by just dwelling for longer on a particular interface. And here you see there are different ways of engagement. Like if you are on the text input, there is a different engagement offered than when you're now here on this additional keyboard. And that works now not only in the browser, like the first version which we submitted, evaluated scientifically, but this is more is also working in general on the operating system interface. Okay, third part, we also have human-to-human interaction, and of course, especially in our academic life, a lot of that has happened in virtual meetings. And certainly one problem that we encounter there is that in face-to-face interactions, we have feedback from the users who watch us, who nod, or who have a question mark on their face, who are happy or sad or bored or whatever. And you lack a lot of this interaction, especially in group meetings where you don't get that detailed feeling. Yeah, it still works in one-on-one meetings. You still can see the face of the person on the screen, but if you then have a group meeting with 10 people or so, it's very hard to get a feeling for what's their behavior, what's their attention. And so the question that we raised then was, and that's specific work with Chandan Kumar, who is not on any of these slides, but whom I want to mention here, was to say, let's look at these virtual meeting platforms and ask, can we extend them by providing some cues that distill how the users behave into some symbolic interaction. Of course, not fully replacing the wide variety of what users offer with their faces, with their nodding or their showing of disagreement with their faces, but can we sort of like symbolically extend even whether a person is looking at the screen or looking at you on the screen, and enable some of that nonverbal communication. Now, this raises a lot of questions concerning privacy, questions concerning like whether it's might even let people feel sort of like intimidated when people look at them and they even see this explicitly. So we have some very first experiments. We have this extension of Jitsi that allows now to plug in intelligent mechanisms, for example, for tracking emotions as people are collaborating in such a small meeting. Here we had a group meeting with 4 people, and you would, for example, see here that this person here receives attention by this other person there. Yeah? And there are many questions, configurations we are still have to look at. For example, should this person see that this person looks at this person? Yeah, I mean, these are some interesting questions that maybe you want to limit this only to see who's looking at you, and that would be a more safe mode. Okay, so this is ongoing work, and that's with this I want to conclude. The general vision being that we are interested in what is the semantics here. What is the computer doing? Can we analyze what the computer doing is for all these many different applications? I think it's quite important to notice that we cannot build a new individual application for each and every interface. Yeah, we have hundreds of thousands of computer applications out there. We cannot tailor them, for example, for handicapped people, one application at a time. We need more something like an AI mediator here in the middle that is able to understand what do these individual applications want in a certain way, and what do they offer, and what are their semantics such that I can help some user over there, yeah, and complement what he or she sees and experiences in a way that he or she has a better experience interacting with this user interface. Thank you very much.
All right, so there's time for a few questions, not too many, but I think a few we could take. Any questions? People are waiting for the coffee. Oh, there's a question, yes.
Thank you, Steffen, for your really interesting talk. I wanted to ask about the last part, the ongoing work. To me, it seems clear that providing these new capabilities would change how people use online meeting tools. And you were worried about the ethics, but I'm also interested in the increases in productivity and communication. How do you plan to develop and continue with this work? Are you going to evaluate it?
So we have some first experiments. And the first experiments are really just about how do even people experience this. Now what we had here were rather small groups. Yeah? Group of 4 to 6 students at most that would collaborate, who would sort of know each other already. So I think we need to draft a bigger plan of how to look at this problem, maybe also doing together with some of the psychology colleagues or so, to better understand what are also the psychological concerns that people will have, because I think there are some, but hopefully we can also provide some sort of feedback. And I believe that feedback at the right level of abstraction may be helpful. Yeah? So you don't need to see in detail and communicate in detail each individual's person behavior, and also there will be false positives, false negatives. So individually this may even be problematic. And at the same time, if we can aggregate information, then this is less of a problem with regard to the privacy and less of a problem with regard to some mistakes with recognition rates.
Let us know if you need volunteers to participate in the study.
Yeah.
If you want us to volunteer, if you want to study it.
Yeah. Okay, so the next meetings at ELLIS. So I have also to say that we asked also people in my research group to participate, and there were like half of them felt really uneasy, and we didn't make anyone to force them to do this, yeah. Yeah, so it's definitely one of the places where you need the switch off button, definitely. Yeah?
All right, any other questions? Yeah.
Yeah, thank you for your talk, Steffen. I was interested in, you showed that you had that system that adapted to specific disabilities. So what kind of baseline or parameter did you use to determine which kind of adaptation should be used?
We had several studies. So one study was taking healthy people in the lab, and it was about comparing their performance when they used the emulation method and when they used the method which would recognize the semantics of the user interface. At some point, we also used some sort of like upper baseline in terms of like just interact normally, but of course, interacting normally is sort of like, is obviously easier for people. And then with regard to the handicapped people, for what I presented here, they only got this new interface, and we asked them questions about how experienced the interface, how they liked it. We tracked their activity, which they could switch off. They gave permission with all the ethics clearance board because they were tracked over a period of 1 month where they had the system in their home. And some people used it for almost the whole time. Some people switched it on once and then never used it again. So that was more like a study, like looking at how, whether people would use it and also for which kind of applications. Of course, what we also don't know is maybe some people used it, switched off the monitoring and never switched the monitoring on again. These are things, of course, that we, by definition, cannot know. Yeah? But what really happened was also that some people kept the monitoring on, and at some point the database would overflow, and that would lock the recording, and then there was something not working, and then they complained. Yeah?
All right, maybe one last question if there is one. Oh, at the very top, all right. Bit of sports today. Over there, okay, even further.
Hello, Professor Staab. I saw your last folio, last slide. You develop an AI mediator. Do you believe the machine can automatically analyze the semantic and extract the semantic from the heterogeneous data type? And because I'm really doing research on that, I research on the foundation model, some big neural network. The first result is this kind of neural network can really understand the semantic and doing some translation based on the semantic, maybe not only for the image data, but also for the text data. This is some field of natural language processing. But the problem is, which data can we use as a meaningful representation that can be used to extract the semantic? Have you doing some similar research? So which kind of data does that?
There are several layers of understanding which also we as humans have of applications. So one level of understanding comes from convention. For example, we know about certain icons on our user interfaces. And some icons which are very familiar for us, like the floppy disk for save. Yeah, my son doesn't even know what a floppy disk really is. It's like it's this funny icon, yeah, that he uses in order to hit the save button. So that's a level which can be well understood. For example, Apple presented a paper, Kai 21, where they basically learned to recognize these icons in order to offer translation, which was at this point not context-dependent translation. It's just like this icon is save button. Yeah? Now, in order to really understand an application, you have to go arbitrarily deep into the domain. Obviously, I mean, if you have like an interface for, I don't know, travel reimbursement, yeah, or or something like that, you really need to understand deeply what all these indications mean and how they are realized in this electronic interface, and that's sometimes worse than AI hard, because not even humans can cope with that, at least not without previous training. And so there are simpler things like translating these icons, very complex things like arbitrarily understanding a domain, which maybe is only understandable when you know the regulations, and there is stuff in between. And of course, everything that we can push will help people that have problems to operate the interface, and maybe at some point you won't have the suggestion how to fill in your travel reimbursement electronically. Yeah.
Thank you.
All right. I think we have to move on. So thank you very much again, Steffen.